Hello everyone and welcome. Today I would like to talk about find peak element. I'll be using binary search algorithm. It's an interesting application of binary search. So let's get started. Specifically, this question provides you a nums array, asks you to find the index to any of the peaks, but you must write an algorithm that runs in O log n time. So how can we do that? There are three situations that can be analyzed accordingly. Situation 1, nums mid is the peak. Situation 2, nums mid is not the peak, but the peak is on the right-hand side of the mid. Situation 3, the peak is on the left-hand side of the mid. Accordingly, we can generate three steps. Step 1, if nums mid is the peak, such as in situation 1, we simply return the mid. Step 2, otherwise, if nums mid is less than nums mid plus 1, such as in situation 2, we know that the peak may exist in the right-hand side of the mid. Thus, we may reduce the search range, like have the left equals to mid plus 1. Step 3. Otherwise, it means nonce mid is larger than nonce mid plus 1, such as in situation 3. In this situation, the peak may exist in the left-hand side of the mid. Thus, we may reduce the search range by having right equals to mid minus 1. Importantly, if left is equal to right, it means there's no more search range to reduce. And because of situation 2 and 3, mid must be the peak. Also, because the nums are all distinct, we don't need to worry about the situation when two numbers are the same. With the background introduced, now let's write the code. So first of all, we're going to initialize left and right point to the first and the last element in the nums array. And we're going to do a while loop while left is less than or equal to right, mid equals to left plus right, divided by 2, and we want to see if nums mid is the same as the peak. So if nums mid is larger than the neighbors, then it's the peak. So we have the expression like here, okay? And we need to take care of some boundary conditions. That is when mid equals to 0, okay? Or when mid is the maximum index. So maximum index equal to length minus 1, maximum index, okay, mid equal to maximum index here. In this situation 1, nums mid is the peak, then we simply return mid. Otherwise, we check whether nums mid is less than nums mid plus 1. If this happens, that's our situation 2. The peak may exist in the right hand side of mid. So we have left equal to mid plus 1. Also, we're going to take care of the boundary condition here again. So it's mid is already at the maximum. Okay. And finally, our situation 3. The peak may exist in the left hand side of mid. Okay, so in that situation, we have right equal to mid minus 1. Okay, and it's guaranteed like when left equals to write mid is the answer, so we don't need to return anything here. And I'm going to fix two small bugs here. So this is larger, and we should put this mid equal to maximum index before this comparison. Okay, and that's our code for this question. Now let's submit the code to see how it works. We submit the code, it's judging, and done. It passed the test. Very good. So finally, we can analyze the code for complexity. So since we use the binary search, it has the time complexity of O of n, binary search. And for space complexity, it will be O1, since we only use constant space variable here. And that's all for this video. I hope you find this video to be useful. Please feel free to subscribe for more videos, and I hope to see you next time soon. Goodbye.